Welcome to the lecture on sequencing problem. In this chapter, we'll discuss the problem of sequencing of job in which number of jobs are to be performed on different machines so that the total elapsed time is minimized or total cost is minimized. There are several types of job sequencing problem arise in the world. All sequencing problems cannot be solved. In this chapter, we'll discuss only a few types of sequencing problem which developed or solved some algorithms. Let us discuss on job sequencing. Let me first explain where is the problem in job sequencing. If 2 or 3 jobs are to be processed on 2 or 3 machines, then the job sequencing can be done by the method of enumeration. The number of jobs and or machines increases, then the problem becomes complicated and the method of enumeration is not suitable. Suppose that we have n machines and m jobs, then we have n factorial whole power m possible sequence. It is time consuming to find all the sequence and select the optimal one among all the sequence. Hence, we have to look for an easier method for finding the optimal sequence. Let me explain some basic terminologies are usually used in job sequencing. Number of machines. It refers to the number of service facilities through which a job must pass before it is assumed to be completed. Processing time. This is the time required by each job on each machine. Processing order. This refers to the order in which machines are required for completing the job. Total elapsed time. This is the time interval between starting the first job and the completing the last job, including the ideal time in a particular order given by the set of machines. Ideal time on machine. This is the time during which the machine does not have a job to process. No pausing rule. This means that the pausing is not allowed. That is, the same order of job is mentioned over each machine. N jobs are to be processed through 2 machines A and B in the order AB. Then this means that each job will go to the machine A first and then to B. Now let me define some assumptions which are called in principal assumptions in job sequencing problem. The processing time on each machine is known. The time required to complete a job is independent of the order of the job in which they are to be processed. No machine can be processed more than one job simultaneously. The time taken by each job in changing over from one machine to another is negligible. Each job once started on the machine is to be performed up to completion on that machine. The order of completion of job has no significance, that is, no job is to be given priority. A job starts on a machine as soon as the job and the machine both are ideal. These are all the principal assumptions. Types of job sequencing problem. Who's usually made job sequencing problem? There are several types of job sequencing problem arise in the world. All the sequencing problems cannot be solved. We consider 4 types of job sequencing problem. Type 1. N jobs are to be processed on 2 machines, say machine A and machine B in the order AB. This means that each job is to be processed first on machine A and then on machine B. Type 2. N jobs are to be processed on 3 machines A, B and C in the order ABC. That is, first on machine A, second on machine B and third on machine C. Type 3. N jobs are to be processed on M machines in the given order. Type 4. 2 jobs are to be processed on M machines in the given order. Now we proceed to discuss on type 1 job sequencing problem, that is processing of N jobs through 2 machines. Suppose that N jobs are to be processed on 2 machines, say A and B. Each job has to be processed through the same sequence of operation in the same order. That is, processing is not allowed. Let A is equal to processing time for ith job on machine A. Bi is equal to processing time for ith job on machine B. T is equal to total elapsed time. The problem is to be determine the sequence in which N jobs should be processed through machines A and B so that the total elapsed time T is minimum. To solve this problem, would like to take a help of Johnson's algorithm. To solve this problem, would like to take a help of Johnson's algorithm. Step 1. Select the minimum of processing time out of all AIs and BIs. If it is AR, then do the author job first. If it is BS, then do the the job at last. Step 2. If there is a tie in selecting the minimum of all the processing times, then such a situation deal with the following 3 ways. If the minimum of all the processing time is AR, which is also equal to BS, that is minimum of AI, BI equal to AR equal to BS, then do the author job first and the job at last. If minimum of AI, BI equal to AR, but AR equal to AK, that is there is a tie for minimum among AIs, then select anyone. If minimum of AI, BI equal to BS, but BS equal to BT, that is there is a tie for minimum among BIs, then select anyone. Step 3. Now eliminate the job which has already been assigned from further consideration and repeat the step 1 and 2 until the optimal sequence is found. Now we'll take an example to show how Johnson's algorithm can be applied to solve type 1 job sequencing problem, that is processing of n jobs through 2 machines. Suppose that there are 5 jobs, each of which has to be processed on 2 machines A and B in the order AB. Processing times are given in the following table. Determine the sequence in which these jobs should be processed to minimize the total processing time. If we apply Johnson's algorithm, the minimum time is given in the table is 2, which corresponds to job 2 on machine A, so the allocation of job will start as 2. Now we eliminate job 2 from further consideration, the reduced set of processing time as follows. Now the minimum time is 3 for job 1 on machine B, therefore this job would be done at last. The allocation of job till this stage would be 2 and 1. After deleting the job 1, the reduced set of processing time as follows. Similarly, by repeating the above steps, the optimal sequence is 2, 4, 3, 5, 1. On the basis of this optimal sequence, the minimum elapsed time is obtained from the following table. Job sequence 2, 4, 3, 5, 1. This is the optimal sequence. The total elapsed time is 36 hours. Further, ideal time for machine A is equal to total elapsed time minus time when the last job is out of machine A is equal to 33 hours. Ideal time for machine B is equal to time at which the first job in a sequence finishes on machine A plus time when the ith job starts on machine B minus time when the I minus 1th job finishes on machine B. So, therefore, the ideal time for machine B is equal to 4 hours. Thank you.